Hey, what's up, everybody? This is Ray, and welcome to the RayWenderlich.com podcast. In this podcast, we'll keep you up to date with the latest app development tech talk. Now, here are your hosts, Dru Freeman and Jenn Bailey.
Thanks, Ray. This is the Ray Wenderlich podcast. Welcome to episode 6 for season 9. This episode was recorded on Monday, the 17th of June, 2019. This episode is sponsored by TripleByte. That's B-Y-T-E, Byte. I am co-host Jenn Bailey here with our one-of-a-kind podcast host, Dru Freeman.
Thanks, Jen. So on today's episode, we have Chiu-Ki. Chiu-Ki he's an Android developer who's very involved in the community. She gives talks around the world, co-hosts a YouTube channel called Android Dialogues, runs the Google developer group in Boulder, Colorado, and also puts on the annual conference 360 AndDev in Denver. 360 AndDev is going to be in July on the 18th and 19th this year, and you can use the coupon code Wenderlich to get 15% off at 360 AndDev.
In this episode, we're going to discuss Android testing. Chiu-Ki, welcome.
Thank you.
It is great to have you on this show.
Thanks for having me.
So, as people know, I'm sort of the iOS person, so I'm going to be sort of sitting back and trying my best on this one, and it's all about testing on Android. So where do we start?
So Android testing is not very straightforward. Why is Android testing so difficult? Why is it not straightforward?
Yeah, I think part of it is just the fact that you're running a test on a device with a UI, right? So whatever you do, if you are just thinking of it as like, okay, I write my app and then I will test it, you will be driving through the UI, and UI is inherently flaky, I would say, right? Because there are a lot of timing issues. Like if you click on a drop down, it may take a little bit of time to show up. So when you're trying to test that, and that's a system level widget, it's not like you wrote that widget. So you click on it and you want to make a selection. Sometimes it passes, sometimes it fails, but not because your logic is wrong. It's because, oh, the test was too fast. Like the drop down wasn't even displayed yet and you are already clicking on it. So a lot of it is because you are directly testing the UI, and that makes things not reliable, right? You don't want your test to fail when nothing is wrong.
So with some of these UI elements being from the system, is there any kind of system wait saying, wait for this UI element to actually do its thing?
So, well, we're jumping right into one way of doing Android testing, which is Espresso library. It does have a notion of waiting for the UI to finish rendering before kind of queuing the event you want to do, like clicking or typing. However, there are certain things that are kind of internal to the widget almost, right? When you have the drop down, it's like the drop down is rendered because the initial skinny version of it is rendered. But when you interact with it, it doesn't necessarily know that I need to now wait for the expanded version to render. So yes and no. So when you initially load the screen, like it does have a notion that, oh, the UI thread is busy. So when the UI thread is busy, then it's going to wait until it's idle. But some other elements doesn't trigger that idle detection. Then your test is flaky. And on top of that, there are other things that is not just the UI, right? Like if you are issuing a network call and it takes a little bit of time for it to come back before your UI will change. And if you didn't wait long enough, then it will test that, oh, okay, I'm expecting this word on the screen, but it's not there. And then therefore the test failed, but it's because it's taking, 200 milliseconds if you have a super fast network for it to complete. So there's a lot of timing issues that make it difficult.
What about the testing pyramid? What does that describe in Android? Why do we have to have small, medium, and large tests?
Yes, the testing pyramid. That's usually the first thing you find when you want to learn about testing. And so the testing pyramid basically, I have a cheat sheet. The testing pyramid is basically saying that you should have a pyramid with a very wide base that has a lot of unit tests, meaning that you're testing just one component, and then one level up on the pyramid is integration, where you're integrating more than one element. And then finally, you have end-to-end tests that's sitting on top, which you run the whole system through. So that's how usually people think of, like, how do you figure out what to test? meaning that if once you know that the individual units are working, then you can start putting things together. That is great as a theory, and it works really well in other platforms, but on Android it's complicated because it's very difficult to have a true unit test, because everything you do probably involves the Android framework, and the Android framework is really big. So even if you're doing something as simple as, oh, okay, I'm going to have intent and I want to make sure that I'm extracting the correct field of the intent. Well, the intent is an Android class. So to be able to use an intent, you need to somehow know that the intent class exists. And you cannot just do that without having a device. And that gets complicated because then you have to deploy your test to the device, wait for it to come online and launch the app and run your test. So the testing pyramid, for the longest time, I've been trying to figure out, okay, how do I test? How do I write a unit test on Android? And I actually find that it's useful in the sense that it guides you the basic principle, but I find it really difficult to map directly into things that I do in Android.
So what % would you say that you actually can unit test? Because on the triangle, on the pyramid, it looks like it's maybe 50% and 30% and then 20%. Yeah, that's just roughly. But you're saying that the unit test doesn't really fulfill that easily. So do you find you do a lot less?
So the very difficult part and kind of the major breakthrough of thinking about Android testing is actually you're not having an app and then you're trying to write all these unit tests and then write a little bit of tests on top. Is you have to structure your app in such a way that you have units that you can test. So to answer the question, so what is the proportion that is possible to do? Well, it depends on how you structure the app, and that is the key takeaway. Like if you are struggling with testing, it's not necessarily because, oh, I just don't know how to do testing. It goes a little bit back to the app itself. Because a lot of the time we think of testing as like a sprinkling on the cake, right? You bake the cake and then you put the icing and the sprinkles on top. But testing in Android is more like you need to structure your cake so that you can think about the individual components. So, and that goes to a concept that I don't know if that's an equivalent in iOS, but in Android is built on top of, it used to be Java and now mostly written in Kotlin, but both of these are compiled down to JVM code. And when you just stay with that, like the part that is pure Java or pure Kotlin without any dependency on the Android framework, then you can run your test without the Android framework, meaning you can run it on your host computer, the laptop or the desktop that you're writing your code to, and you don't have to deploy your code to your device or your emulator. And that is one big way that you can make testing easy on Android, which is you think about, okay, is there a way that I can write part of my code that doesn't involve the Android framework at all, and then I can have a lot of small unit that I can iterate on very quickly because you don't have that time of having that APK deployed to your device, wait for that to install, for the Android system to acknowledge that, okay, I got it, and then launch the app. So that's a very, very long answer, but that kind of illustrates why testing is difficult, right? Because when you don't have the framework in your mind of how everything fit together, and you're thinking, oh, there's this testing pyramid, so how much of unit testing should I do? Well, actually, that's not going to get you very far, because once you get into your Android app and you're like, what is a unit? You kind of have existential questions like, what is a unit? I don't know where to cut my thing so that I can have unit tests.
Right. So go ahead, Jen.
Oh, is that what they mean when they use the term test-driven development? Is like writing, thinking of the tests first and then writing the app to satisfy those tests rather than writing the app and then coming up with tests for it?
Yes and no. So test-driven development mainly means that, yes, you, instead of write your app, you write a test with the criteria that you want it to pass, and it will not pass in the beginning because you haven't written your app yet. It's literally not there, right? So you start to write an app and you launch the app. So that is kind of orthogonal to whether you're doing unit testing or integration testing or bigger chunks of tests. But I said yes and no, so that's the no part. And the yes part is that to be able to do TDD, test-driven development on Android, it will serve you very well if you structure your app such that you have these pure Java classes that you don't depend on the Android platform, because that's how you can very quickly actually close the TDD loop, right? If you are able to make a change in your test and make a change in your app and run, and within a second know that it passed or failed, then you can actually iterate, right? If every single deployment takes upwards of like half a minute, then you get distracted and then you go watch cat videos and you forgot that you're trying to test. So testing, you can, I mean, you can absolutely do the test-driven development with UI level testing, but on top of being like the need to deploy your app, you also need to wait for the actual UI to be exercised, right? So if you write a test that says, okay, say I have a calculator or a pin lock, right, that I need to press button 1, 2, 3, 4, you actually have to wait for the emulator or your device for your test to send those commands over and for the command to be received by your app and react. So that's just too long to be feasible.
For some of the newer Android listeners, we've talked about unit tests, we've talked about UI testing and TDD. We also mentioned integration tests. Can you help for newer listeners differentiate the difference between a unit test and an integration test?
That's unfortunately the answer is no. I've been doing Android for so many years. I still don't know what is an integration test on Android, which is why I thought the testing pyramid was just really not appropriate for Android. Instead, so I touched a little bit on how you can think of it as two different kinds. Like one is the pure Java code, which you can test on your host computer. So that's what I call the JVM test. And then the on-device test. So that's got one dimension. And then another dimension will be whether you are exercising the UI or you are just testing the non-UI logic of your app. So that's much more helpful. And as you, okay, I need to my cheat sheet again because I have a whole quadrant that I guess we can post a show note on how to divide up the grid. So a JVM test is very fast to run, right? So a JVM test that is exercising the non-UI part of your app will be sort of equivalent to the bottom part of your pyramid. You want a lot of these, mostly because they are so fast to run that you can put it on your CI or on your continuous integration to verify the logic of your app without necessarily waiting for like an hour to spin up 10 emulators to run all your different UI tests. But then you also want to make sure that the part, because you cannot write an app without Android code because it has an Android app. So you do want to exercise the part of your app that does use Android code, but with a good foundation with JVM tests, you can have not as many of those slow tests. And for those part will be more like almost sanity checks to make sure that this app launches. And people laugh, right? When you go through a tutorial that like they will show you like, okay, we have a test that launches an activity. And you're like, okay, great. I mean, it's a tutorial, this is fake. But it's actually has caught bugs for me before. So what I had was I actually had an activity that has an embedded Google Maps in it, which I upgraded the dependency. And I was doing something, I forgot what I was doing, but that crashed the app with the new version. So the fact that you can launch activity is worth testing, even though it sounds stupid. Of course, I can launch the activity. What do you mean that you should test that? However, like that's the level of sanity check that I'm referring to. But like after that level, the intricate logic of like, oh, but like if I come to this activity and it's not logged in, then I should show the login message so that there's a button that's visible so that people can click and log in. If you can move all that logic, like the determination of what button is visible, right? Because that's just a Boolean, right? Like is login button visible or not, rather than launching the activity and checking whether the widget itself is visible. Like if you can do that separation, then you don't need to test the actual on-device part too much. So you can have good confidence that your app is working, but still have that sanity check level of, okay, I know that the logic works, but let's make sure that the basics are covered, the basics of how the app is deployed and run, and make sure things don't crash on launch, which happens. People didn't realize that.
And of course, you throw in one evil little other test, which is with a new version of a component, things break, so you wind up with regression testing as well.
Right.
Because once you have your test suite written and you know things are working, you always have to back up and say, okay, we've made some changes. And whether it be a change to our code or whether it be a change to the new version of Google Maps or a new version of Google this, Google that, something could wind up breaking backwards.
Right. Yeah, and that is why it is very good to have a lot of unit tests if you think of the testing pyramid, and in our case of pure logic, pure Java tests, because those tests, you would not like take them out essentially. Because if you have a lot of UI tests, and like I said, they tend to be flaky, and it's failing your continuous build, right? And you're like, I don't know why it's failing, it should work. And you run it 10 times and it passes 8 times but fail 2 times, and it's just not providing you value, then it will be sensible to take that test out of the test suite, because look, it is not actually indicating that I should be addressing some problem, right? Versus if you have very reliable pure Java test that runs very fast, and you know when something fails, then you have a regression, that you have confidence that the test is actually useful, rather than like, yeah, you know, the test, like sometimes it fails when it shouldn't fail, so I don't really think I should bother running it because it takes time. So
I found that some of my tests, when they become intermittently failing, the problem is that test is encompassing too much. In that I've actually tried to test too large of a unit or maybe multiple units. And as a result, sometimes it works, sometimes it fails. But the truth is that maybe I've got multiple units. And if I break them down into smaller chunks, I find that, no, something is failing all the time, but it's not being called all the time. And that's
for sure. Yeah, that's one very big pillar of testing, is you want to modularize, right? You want to have small points when you can verify the functionality, so that when something breaks, you know that, oh, it's because component A breaks. It's not like this big soup of things and it's broken, and you have to go individually fish out the potato and and the carrot and all the different components, and because you don't know, right? But if you have your very small unit, then when something fails, then you can pinpoint, aha, let me check why this is failing, and then you can work much faster in locating the problem. So, but like going back to what I said earlier, that requires you to write your app in such a way that you have small units, right? Like if you wait until after you've written everything, like, oh, now I have some tests, let me find what the units are. They're not going to be there, because it takes discipline. It takes a lot of discipline to have those modules. So when you are writing your app with testing in mind, and actually writing tests along the way, which like Jenn said, like a lot of people do that via TDD, then that has that reinforcement loop, right? Okay, let me write some tests. What is this unit? And then it will help you structure your app so that you have actually different components that call each other, and then you can separate out, say, okay, I'm going to test just this component, and maybe you'll mock its dependency with another component, so that you know that if something is broken, it's this component, not because of the incoming component that is faulty.
So it sounds like in Android world, if you can keep your business logic, your business models as separate as you can from the widgets, from the UI world, that makes your disciplining of the testing go much easier. If you can really try to just keep that in a narrow path away, and then only at the times you need to talk to the widgets, that's when you're crossing over into that UI world.
Yes, it's easier said than done, but yes, that's the basic principle. Because at the end of the day, right, like when you have an app, everything is driven from the UI. And so to be able to cross that layer from the UI to the non-Android code, it takes a lot of acrobats to, for example, if I don't know, like I always say, if iOS has the same thing, but in Android, you may hear all these acronyms like MVP, MVVM, MVI, all these architecture patterns. And the reason why we have all those things is because we want that boundary. And this system is MVC, right? Like, which is also this alphabet soup, but C is very big. Like the controller, which we don't have actually a class called controller, but the activity is very similar to controller in the sense that it controls things, but it also like make widgets visible and not visible. So it's all mingled together. But with like a pattern like MVVM, for example, the VM, the view model part is your logic part, like, and you want to put all your logic in there, and then you have interfaces that is defined in such a way that it doesn't involve the Android framework, so that you can just test that. It is a lot of extra work, to be completely honest, because if you want separation, that means there's a lot of ceremony and interface, right? Like if you want to be able to talk to Android without talking to Android, what you do is you erect a barrier by having an interface. You are saying that, all right, I have a function that is called, for example, show error, right? And this function is taking a string. So the part that doesn't involve Android, it has the string class because it's a Java class. And then you need to implement this interface that has the show error function in the Android world, so that once you receive this, the actual UI will show the error. So you're testing the fact that I am calling the show error function, and trust that when you actually cross over to the Android side, your error view dot set text is doing its thing, which, I mean, at that point, you can't really test everything, right? If you cannot trust that the system will display a text string when you ask it to, then it's there's not much you can do, right? So if you're able to separate that and say, okay, in my little app, what I wanted to do is when this condition happens, I want to show an error message. That doesn't necessarily involve Android. I just want to make sure that I call the function to show the error message, and then in the actual app, it will show the message under the Android framework.
We talked earlier about network testing and dealing with things that are being done by a network. If you're dealing with something that's on a server client level, where you're creating an app that is in a server client world, are there good approaches to doing the testing for that?
Yeah, so one thing that I highly recommend is to use a mock server, meaning that instead of actually talking to your real server, even for a staging server, I don't want any external dependency. I want a server that runs in memory alongside your test. So you're essentially talking to localhost. And what that means is when you say submit, so let's say we have a comment form where you just submit like, oh, today is bad weather because we had hail, and you just want to submit that comment. So instead of registering it in your server, what you want to do is you want that mock server to capture that information and then verify that, oh, this information has been received. And the reason why this is better than talking to, of course, like talking to your production server is even worse, right? Because then you will have that data actually persisting in an environment where you will then just have a lot of strange data that only exists because you're testing. A lot of people, I mean, that's already one step better if you test it, point it to your staging server so that your real user are not affected. But even that is not good because of the state problem, meaning that if I have submitted one comment and I run this test again, I submit another comment, and I submit another comment, I submit another comment. So you may have 100 comments on the staging server. And if you have a later test later that says, okay, I submit a comment, I want to verify that the list is now 1 unit long instead of 0 unit long, the second time you run this test against that staging server, it will fail because you have submitted the comment twice now. So it will have 2 comments instead of 1. However, if you have an in-memory server that you just spin up every time you run your test, it's in memory, right? It doesn't remember that last time you run this test, you have already submitted a comment. So then it will be a clean slate. So every time you run, it will consistently be like, okay, it will be from 0 comment to 1 comment without having the previous test changing the state of your server.
That
Yeah.
makes sense.
Yeah, and it takes a little, again, this is kind of the recurring theme of testing. It's like, okay, that makes sense, but how do I do that? And that takes a little bit of, again, structuring your code, right? Because you need a mechanism so that when your app is running normally, you're talking to your normal server, but when your app is running under test, it's pointing towards your in-memory server. So that gets into dependency injection, which is a big word that sounds really scary. But yeah, and I think part of it is just like, I don't want to do this extra thing. But the reason why dependency injection is needed is because you have a different dependency when you have a different environment, essentially. When you have your production environment versus your testing environment, you want to change the dependency on your server. So that is why I think a lot of people end up talking to the staging server, and then they do this acrobatic of like, okay, I will submit this comment, and then in my tear down code, I will like delete it so that it cancel out. But it is actually more difficult after a while. If you always have to undo your action, it's actually better to set it up so that you are always spinning up a clean slate. And that goes with the server, or if you have a database, or anything that is going to change the state. Like, you want to make sure that you run it always from the same initial state so that you have predictable behavior. Because otherwise you can't really verify your test.
That is great. I'm glad you brought up dependency injection, because that was my next question. Where does that fit in? And would you use dependency injection on an app pattern if you didn't have testing in mind?
I don't. And to be completely honest, I actually have tried watching and attending talks and reading blog articles about like more sophisticated dependency injection where you have different components and things of that kind. And then I was like, I don't know if it's just because my app is not complicated enough. I don't really see a lot of value in that. But for testing, the case is very clear. Like, it's the fact that when you have dependency injection, essentially you are trying to define all your external dependencies. And then during the test, you can change that. So another example of a dependency is date and time, right? So for example, if you have an app that shows today's date, you can't really test that, right? Because the date changes every time you run this. So that becomes a dependency that you will want to put in your dependency injection component, essentially, so that you have a clock that you are able to mark. So I always have the same date every time I run the test. So dependency injection for me helps a lot in testing, because you can figure out what is external, and then you can assign that to dependency injection and then inject a different dependency during test.
Great. Like in the keypad app example, where would dependency injection fit in that case?
Well, it depends on what your keypad does. Like, I'm imagining a keypad that is, for example, a lot of the times when you go to a coffee shop and they have a bathroom, they have a pin, right? So if the pin is completely separated from anything else, it's just one unit, then you don't really have any external dependency, right? However, if that pin, for example, actually receive like a daily change from a server, like, then your server will be the dependency. So a lot of the times is basically you want to look at your, well, it's not just app level too. Like, a lot of the times, so for example, in the pin application, maybe you have a unit within the activity that is a separate class that is just a verifier that you got the correct pin. So that unit, if it retrieves the pin from the internet every day at 6 o'clock or something of that kind, then you may want to have a test that have a mock server that will return a different pin depending on time of day, right? So then in this case, you have two, which is why dependent injection, it sounds complicated, but once you have it defined, it actually makes your life easier. So you have the pin lock, which depends on the server, and the server depends on the clock. So if you don't have to manually specify that, oh, when I'm creating a server, I need to make sure that I'm getting the mock clock when I'm in the test environment, I'm getting the real clock in the production environment, because when you have a dependency injection framework, what it does is like, okay, I know how to provide a clock. Whoever needs a clock, here you go. It will be the same mock clock that get implemented. So in that case, when you have your real app, then it knows to use the actual time. But if you have a have a testing situation, then it knows that the keypad is taking the mock server and the mock server is taking the mock clock.
See, this is where my brain sort of went pop, because I'm used to iOS, which exists in the iOS world, and then I forget in Android you have the Internet of Things, so you can actually have a small object that actually is running Android on it. And the idea of you had mentioned a keypad lock, and I actually pictured actually having to have a unit test that says, does the lock unlock, does the lock relock, does it, having tests just to make sure that the device does what it's supposed to do.
Yeah, I mean, this example may or may not be an app. I mean, it could be just an app that, I don't know, transmits a beep into the the lock with the right pattern so that it opens. But I use it as an example because it's simple, right? It has very few components versus an actual app where you depend on the network, but also Google Maps and all these other different things. But yeah, I didn't consider the fact that this could be a physical object.
Oh, that would be even more fun to test.
Yeah, that's another level of testing.
Let's see. So could you give us some tips on how would you organize an app properly for testing with the MVP pattern? What would that sort of an overview of what that would look like?
Sure. Yeah. So coming back to the keypad example, if you write this app without testing in mind, you probably will have a XML file that displays those 10 digits so that people can put in a pin, and then the activity will then record that, okay, these buttons are pressed, and once 4 buttons are pressed, I will verify that this is the pin that I'm expecting, and then I will have either maybe a red light turn on and a green light turn on, right? So let's say that's your app. So if we want to structure it using the MVP pattern such that it is separate, like the UI and the logic is separate. So what I would do is I will have so MVP, actually I should first of all define what it is model, view, presenter. So the model is, you can think of it as those data classes. In our case, in the pin lock, it sounds kind of silly if you define a key on the pin lock as a model because it's just an integer. But it's a very simple example, right? So the view, confusingly, is not the view class in Android, but it's either your activity or your fragment. So the screen essentially is your view. The part that is the UI component where you can see and you can also interact with. So you also need to respond to events such as if someone click on it. And the presenter is the logic part. So the way you do it is, again, this is very confusing because when I first did it, I didn't realize there's one other thing besides MVP is the view interface. So this is the line you draw between the view, which is, again, I said like the activity, right? So that's the Android part, and the P, which is the presenter part, which needs to be completely in Java. So the first thing you would basically do when I want to kind of refactor that app that I said, right? It just takes your keypad directly in the activity and then store it so that once you have reached the threshold of 4, it will evaluate and then turn on and off the red and the green lights. So my view interface will have a few functions. So first of all, it will have kind of a click listener, all right? So for example, I will call it on key clicked, right? And that will be in my interface. And then I would make sure that I don't think about it without typing on my IDE and make sure that things are compiling. So this thing is essentially a call that when your activity on click listener on those buttons are called, you will want to call the essentially presenter dot on key pressed, and then you pass in the integer. Right, so that the presenter then will have an internal structure that is an array, and then it just fills it up. And then what it needs is that once the 4 is filled up, so this on key pressed function will need to be able to call back onto the activity and ask it to either turn on or turn off either the green light or the red light. So that is also in the interface. So the interface will have a function that says change green light, and then it will have a Boolean true or false, whether you want to turn on or off. And you'll have another function that is change red light, and then will be on or off. So that will be also on the interface. Then what you have to do is you have the activity implement this interface with the 2 functions, the change red light and the change green light, so that when you call it in real life, it will actually change the buttons. And then you will have the presenter implement the other function, which is the click listener function. So this is very difficult in a podcast format where I don't have diagrams, but so let's just, it's okay if it's a bit fuzzy at this point. So then I will walk you through what happens now that you have this interface severing the logic from the UI. So now when you press a button, what happens is when you press the button, the on click listener calls the presenter, and the presenter dot on key press function is called. And inside this function, it will append this number to the array and then check that if the array size is now 4, then I will verify that the content of this array is the expected pin. And if it is indeed, then it will call the view, which is passed in to the presenter as a constructor. So when you make this, exactly. So when you make this presenter in the activity, so in the activity you have to create the presenter. So you pass in this as the view in the constructor, and then this view implement that interface, which is consisting of those 2 functions, like changing the state of the green light and the red light. So then inside the presenter, I have this view which I got from my constructor. Then I call view dot change green light to true, right? If it's a good pin. And then also you have to call change red light to false, right? Because otherwise you have both red and green on if you have previously made a bad attempt. And then of course, the opposite, if your pin is not matching, then you will also need to call the green light to false and then the red light to true. So with all that, now you can run your test. I know, it is a lot of test setup. So in your test, you are testing the presenter. So in our case, we're not really testing the model because it's so simple. It's literally an integer, so there's nothing to test there. So in your presenter, when you're creating the presenter in your test, instead of the view being the actual activity, you're going to pass in a mark. So this is how you can test this without Android, right? If you're still passing in the activity, then it's still Android code. So you have a mock, which then introduce another concept. To write a mock, there are multiple ways of doing that. You can either write, like kind of roll your own fake object that keep tracks of things. What I mean is, so for example, in this case, I may have an object that has those function that is on change. Change red light and change green light, right? And then as long as this mark implements those interfaces, the code will compile.
Oh, and
In
so
other
would
words,
that be written in like Kotlin or Java? Like
yeah,
just another Kotlin class that doesn't
yeah,
use the anything like activity or anything from the Android?
exactly. It will be either Java or Kotlin, but it will not use any Android specific functions.
Okay.
Yeah. So then once you create this presenter in your test, then you can run scenarios like, all right, so I have a presenter and then I call presenter.onKeyPress1. And then after that is called, you can then in your mock object, in that view, you can verify that nobody called the on like change red light function or change green light function because it's too early. There's nothing to change at that point. Right? I mean, depending on your implementation, maybe you always turn it off every time a key is pressed. So you can either verify that the function is not called or is called with the value false, right? So you press 1, so then you call key press 1, 2, 3, 4, and then once that's done, then you can verify whether you are expecting the change green light function to be called with value true or the change red light function to be verified with value false. And the nice things about cutting it out like that is that then you can test all kinds of scenarios, right? You can test that, okay, I first give it a bad password, I give it a good one, and then the light is what I'm expecting, or I can press the same good password twice, will it still open the second time? And then you can build on top of that and make more complicated situations. But the nice thing is that you are not actually pressing any Android buttons at that point. You're just calling these functions and telling the presenters, like, trust me, somebody pressed that button. And in real life, someone did because you hook that up with the activity. But during the test, you're just saying, I don't know how this thing got pressed, but it just got pressed. So tell me how you will react if someone does this sequence of action. So that's how you will do that in the MVP scenario.
Wow, that makes perfect sense. It's been wonderful talking with Chiu-Ki. Thank you, Chiu-Ki, for taking us through the model view presenter pattern and explaining how to keep the logic separate in the presenter away from the Android SDK so it's a testable module. Okay, coming up in the second half, I have some questions for Chiu-Ki regarding an app that I'm trying to write and how I could test that, and also some general questions about testing and terminology. But first, a message from our sponsor, TripleByte.
This RayWenderlich.com podcast is brought to you by TripleByte. Applying to programming jobs sucks. You have to put the right keywords in your resume, you spend hours and hours on phone screens, take-home projects, and that's assuming the company even responds to your interest or your cover letters. Well, if you're a software engineer, TripleByte can help.
They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, and if you do well, you get to go straight to the final interviews with the companies on their platform. It's like the common app for software engineers. TripleByte does not look at your resume or where you went to school. All they care about is if you can code.
And I can appreciate that. Being in the industry for 35 years, I'm entirely self-taught. My undergraduate study was in theater, and I left school to do my first job, so I don't carry a bachelor's, no bachelor's of arts, no bachelor's of science, and that's the one thing I'm often trying to hide or misdirect on my resume. With TripleByte, they'd care more about the coding experience that I have and not worry about that one little fact.
Apply now at triplebyte.com/Ray. That's triplebyte.com, byte, BYTE, as in 8 bits. As a special offer for listeners of this show, if you take a job through TripleByte, they'll offer you a $1,000 signing bonus.
And thanks again to TripleByte, that's Byte, BYTE, for sponsoring this and every episode this season of the Ray Wenderlich podcast. Back in with section 2 of the show, Jen has a whole bunch of testing questions now that help her find her way through an application she's been working on. Jen?
Hi. So I'm fairly new to testing in Android. So how could someone who's never formerly tested their app before get started with testing without becoming overwhelmed? Because there's so many different types of tests and so much to do.
Yeah.
Where would a good starting point be for someone who's interested in breaking into testing?
Yeah, I would recommend not trying to test the app that you have on hand as the first thing, because like earlier, a lot of this is about structuring your app in such a way that it's testable. So if you don't have a good mental model of how Android testing work, you don't really have a way to look at your app and say, aha, okay, I think this is the smallest unit that makes sense to test, or I should refactor my app so that I have a testable unit. Because a lot of the times what you will end up doing if you just write your test for your own app is you will start with the UI, and then you will realize that things are flaky and like it's not passing, and then you will lose hope. I don't want people to lose hope. So what I would recommend is actually something that has an app that comes with it, so that you try to write the app and the tests in a simpler environment, so that you kind of get the basic first, like basic concepts of, well, even like how do you even run an app that has a test in it, right? If you're running in Android Studio, you need to press green triangle on the gutter of your IDE, like things like that, right? The very, very basic. I was, but trust me, I've been burned many times, and it's not just for testing. A lot of the times, every time I try something new, and I'm like, all right, I'm just throwing it into my main app, and then it's just a tangled mess, and I don't know what I'm doing. So I would highly recommend doing it in a tutorial environment in an app that is completely separate from your own app. And then once you get used to like, aha, okay, so this is what it means when I'm testing, and then you have that knowledge to then use that lens to look through your app and see, okay, now how do I apply that to my app?
Great. So is testing different when you're dealing with a database? Is there a way to specifically unit test your database?
Yeah, great question. So like I said, a lot of the times is defining your modules before you can do all the unit testing. So let's say that you have something that depends on the database. So much like the pin log example I talked about earlier, where you have the log that depends on the clock and then the activity depending on the log, you will have a unit that the activity depend on, which, like, you know, I don't know what your app is. So let's say it's a to-do app, and you have.
Oh, great. I could describe my app for you a bit if you like.
Yeah. So yeah, let me know how are you using your database so that I don't have to talk in the app.
Okay.
Examples. Yeah.
So if it's like a to-do list app, and I do have an interface for like adding a to-do item or deleting a to-do, like the insert, that is extrapolated behind a interface. And so hopefully it is using the MVC pattern.
Okay. Yeah, so let's say that then now you have your activity that depends on this logical unit that have functions like add note, delete note, list note, right? Let's say we have these three functions, right?
Correct. So that's exactly what I have.
I would just call this thing notes. I mean, or notes, like I don't like, naming things is really hard. So I don't want to use the word repository because that has meaning. So let's just call it notes store. How about that? So it's a notes.
Okay.
So this notes store will then depend on the database, right? So your database class will. I mean, there are multiple ways you can do this. Assuming that you are using a SQLite database.
I am, yes.
Okay, good. So then when you do that, usually you have to have like create the database helper, and then you can talk to the database, right? So the way I would do it is then you will have your note store in the constructor takes in this database helper. And one very important thing is that in your database helper, you will define a constructor that can allow you to change the path of your, because then what happens, so then what happens is that when you are same file, right, so that next time when you've written a to-do, why do I call it notes anyway? Now it's notes. When you've written an item and then you shut down your phone, you come back, it's reading from the same store so that you retrieve the same item. But test, what you're going to do is you're going to define it. So in Android, there are ways that you can ask for the system to give you a temporary directory that's specific to your app, so you're not overwriting other people's stuff, right? So you ask for the temporary directory, and then maybe you will create a file name under the directory that is dependent on the date and time, and a random suffix. Just make sure this is unique, right? So that you know that the database will start off empty because you're creating a new file, right? So you create a database helper, but give it this new temporary path when you're testing. Then during the test, you can call your notes class with functions like adding, listing, removing, without worrying that you're polluting your actual app, right? And then, to be a good citizen, like when you shut down the test in the delete, in the shutdown, in the tear down, you can say that I will then delete the database. But you don't want to do that in real life, right? If you're doing it in production, then like, all the stuff that you stole will be gone. So that is how I would deal with having a database and wanting to test it, is making sure that, again, it is dependency injection, right? If you think about it, the database helper depends on the path that this database is stored at. So in production, you are always having the exact same path, versus in test, you're generating a new temporary path every time. So that dependency is what makes your testing environment different from your production environment.
That is great. Thank you very much for that advice. Definitely helpful. I've heard a term, this might be unrelated, but I've heard a term, hermetic environment related to testing. What does that term mean?
Yeah, so I mean, that's actually what we've been talking about. So hermetic, if you think of a hermit, right? He hides in a cave. He doesn't talk to anyone. He just do his thing in the cave. So that's what hermetic environment mean. Like the unit that you're testing should just hide out in the cave and do its own thing without any influence from the outside. Now, it takes a little bit of work to be a hermit. So in the case of a test, you can't really have all the units be self-contained, right? They will have dependencies, right? Like your app, when you have your notes store, you are depending on the database. So, but then how do you make it hermetic? You can still make it hermetic by the technique that I've been telling you about, which is in the test environment, you control those influences. So in the sense of the database, instead of having the production database, which I don't know how many times this got written and deleted and how many entries it has, but if you want to create a hermetic environment, then you always start afresh, right? You always have this new file that you are using as the dependency. So that's how you create that hermetic environment. It doesn't mean that you are completely sealed off from the external world, but it means that when you have that external dependency, you're actually providing a consistent version of it. So that's how it's hermetic. It's hermetic in the sense that the dependency is contained within the test environment and you're not reaching out to somewhere else. It's all inside the test. So in the case of what I talked about earlier of a clock, instead of it actually knowing what day and age you live in, you are in that hermetic environment where I just tell you, today is 1999. Like, this is the year we live in now. And then you write your test assuming that. And so you know that if you have a Y2K tester and then it goes to the next year, you can test that, right? Otherwise, Y2K has come and gone and I'm not going to be able to verify that my Y2K app still works, which I don't know why anyone would do that. But if that's the case, if you have a hermetic environment, then you are able to control which year we are in, versus if you don't have that hermetically sealed environment, then you are depending on the current year.
That makes sense. Now, when you're testing an app that would have a database, would it be better to test that sort of an app on a device or the emulator, or is there a difference?
There isn't really a difference. The reason why I would choose with emulator versus device is that a device I have to plug it in. So I know it's a very simple consideration. So if your computer is powerful enough to run an emulator and run your IDE at the same time, then these days the emulator is actually pretty good. I mean, when Android first started, it takes forever to start an emulator. So you're just sitting there waiting. But like now, the emulator boots actually very fast. So I would use an emulator unless I really want to verify that it works on a specific device. The other advantage of using an emulator is that you can have different versions of Android, right? I mean, I don't know how rich you are, but I really have just one phone, and maybe I'll buy an extra one as my test device if I'm a freelance developer, so I don't have a giant budget. Maybe you work in a big company and you can have a whole wall of devices. But if you are not in that situation, you can use the emulator, right? I can test and make sure that it works in the latest version of Android. I can make sure that it works on the version that my app supports back to like the oldest one. I can set the environment so that it is a very memory constrained device. So I can test the behavior if it runs out of memory, right? That kind of thing, where you don't necessarily want to have your actual phone like make it run out of memory. But if you are defining your own emulator, you can set up so that the emulator itself doesn't actually use a lot of memory. So you will be able to run into situations that you would like to test. So the emulator gives you that flexibility.
Great. So one thing about testing is I have worked in situations in the past where we were not required to do formal testing. And we, a lot of times, would test our applications by just pushing all the buttons, putting in test data. At what point does an app get to large enough that testing becomes necessary? When is it most often required, or when is an app large enough that it's advantageous to use testing instead of the old-fashioned, well, I'm just going to try everything I can think of and see if it crashes and then deploy it and take customer complaints. So I was in a different sort of company where we wrote a lot of code on the fly, and we wrote patches with people right on the phone. And testing was something that we just kind of did on the fly, and we released a lot of bad code that, we basically, our testing was to deploy it.
Well, but I have an answer that surprised no one, since you're talking to me and I love testing. Basically, my rule of thumb is if you plan to throw away your code, then don't test. If your app has any longevity, you should test. So what I mean by throw away code, if I'm going to a hackathon, right, I just need this app to hang on for dear life for 24 hours and work through the demo. Don't write tests, because no one's ever going to touch this app after the hackathon, right? And I mean, that's an extreme example, but there may be situations where you are, for example, like what I was telling you earlier, right? Like when you asked me, how do you get started on testing? I said, don't write it on your actual app, write it on something different. And I use that principle for something. For example, if I want to learn how to use the room library to store my to-do rather than using the SQLite database straight, right? I will probably not muck with my actual app right away, but instead I'll write a simpler app that literally all it does is I will create this room database with maybe 3 columns, and I will try to write to it, and I'll try to read it back, and then I'll try to delete it so that I exercise all the functionality so I know how it works. And then I go back to my main app, right? So in that case, that is a throwaway app, which arguably you should still test, because then what you can do, once you figure out how to use the database, then you can figure out how to test the database, and then you can go back to your app and do the testing. But fundamentally, the way I think about testing is not necessarily that you are using testing to verify that your app is, when you click this exact sequence, is giving you the exact output. What I use testing is kind of documentation, to be honest, right? If you're in a team where, it's not just you. I mean, even in a team that's just me, that's me and me from 6 months ago, which I don't know who that person is. when I read the code that I wrote 6 months ago, I'm like, what is this supposed to do again, right? But when I have a test then I can read out the text and say, oh, okay, so this is why I have this if statement in my code, is because if somebody press this button too fast or whatever, like if I for some reason get into this situation when I'm deleting a note that doesn't exist anymore, it blows up, right? So that's why I have this if statement that says, if the size of the database is 0, then throw an error, like a friendly message, right? So if I have the test case, then I know that these are working, right? Like if I just comment my code, they can fall out of sync with my code very easily, because who has the discipline to always read the comment, make sure it's still doing what the comment says? But if I have a test, then if it fails, then I can programmatically know that something changed, right? So I like using tests as a way to clarify my thinking, right? Like it helps me write code in such a way that it's modular, so that each unit really only does one thing. Because once you have a unit that's too big, you will realize that when you test, it's like working against you, right? So having that test in place just give me that discipline of making sure that, okay, I am documenting what I'm doing by writing down the test cases. And also, when you have things like, oh, the customer said that if you do this, and then you do this, and then you do this other thing, this break, and you're like, oh yeah, it does break, then nobody's actually going to go back to your bug database and realize that, oh, 2 months ago we had that problem. Let me press the exact same sequence of buttons, and the regressions essentially, right? So when you have it in your test, then you remember that 2 months ago this was a problem. Which is why longevity is kind of the test of whether you want to write a test. Like if you are going to come back later, it helps you document what you're trying to do, and it helps you catch regressions.
I find you have to stay on good terms with the me of 6 months ago, because as long as you're on good terms with them, you have somebody who can translate the me of 12 months ago, because
right.
Right.
Yeah. I know.
They were on drugs.
People don't realize how much of an enemy we become of ourselves once we age beyond a certain point. Just like looking at my own code, I'm like, why did I do it like this? But
remember the important phrase there is, it seemed like a good idea at the time.
Yeah.
Exactly.
I'm going to pass that answer on to my old colleagues, because do you find that all the time writing testing, does it take you a lot of time to write all those tests versus all the time, and I'm thinking of their code base, which is 20 years old, all the time they have to spend fixing the same problem? So that's actually and new staff members fixing the same problem. And the me of 6 months ago.
That reminds me, another reason why I do it like that, that I actually will spend the time to write the test, is because sometimes I'll work with a server team and we are rolling out a new feature and the server team is not ready yet. So I don't really have a way to start working on the UI. However, if I have a test environment set up such that I can have a mock server, then as long as we agree on the REST API, right? Like what kind of JSON object do I send? What kind of JSON object do I expect to return? Then I can proceed, right? I can have my my mock server respond the way that it will once the server team is ready. So I'm not sitting there waiting for them. As long as we we agree that this is how the protocol is going to work, I can actually start working, which actually I don't actually tell my team that this is what I do. So they think I'm a genius, because once the server lands, I'm like, oh hey, the app is ready. I thought it's 2 hours, which is not true. I've been working on it for 3 days, but they didn't know that I have this secret weapon where I am mocking, which then it serves as a test as well, right? It's not like I mock and I just throw it away, which sometimes, before I can't figure out how this testing thing works, I would do that. I don't know if you've done it before. You hard code into your app and you pretend that this is what the server returns so that you can render that error case, right? Because I'm not going to be able to always run into the situation where my token for login expired because it takes 2 weeks to expire, right? Who has time to sit around to wait for it to expire, right? So then I would like hard code in and just like say that, okay, I have a bad token and now this is how my UI should look. It's kind of clumsy because then you have to go in and delete the part that you put in just to fake that situation, versus if I have a testing setup, then it's separate. It's not a part of the app, it's in the test. And then I can run the debugger when the test is running, right? Sometimes I will fake that situation with the mock server or whatever external dependency you have, right? Like you may be depending on something different. And then I'll put a breakpoint, and then I can actually look at it. I can take a screenshot and post it on my Jira ticket or whatever, Trello, whatever system you use, and say, hey, this is how the error case looks like, right? So it's test-driven development, but not in the traditional sense that you are just verify that things are not failing, right? You are actually driving your development by using the test framework to come up with situations that you will need to deal with.
I had done a bunch of REST code, and I actually had a local server that just had a whole bunch of pre-generated JSON, including error JSON, to make sure that everything would work right.
Right, yeah, and that's much easier to do when you have some kind of setup ready to go, right? Rather than every time you come in and you're it's like hard coding that situation in. And testing is a valid way to do that.
So this is on a new note, but what is Roboelectric? Would you advise using that? When would you advise using Roboelectric? I see that all over the documentation.
Yeah, so remember I was talking about how you can think of, instead of the pyramid, you can think of it more like a table with two axes. So one side is JVM versus on-device, and the other one is non-UI versus UI. So JVM testing is the preferred way because you don't have to deal with the emulator and it's much faster. And it is fairly obvious once you have your module down to use JVM for non-UI. But if you want to be fast and you also want to test your UI, then you have kind of like I want my cake and also eat it situation. Because UI is a part of the Android framework. Without the Android framework, there is no UI. So Roboelectric is a solution that someone came up with that mocks the whole UI framework. It mocks the whole Android framework. This is what the basic idea is. So instead of how I was telling you that, oh, you can have an interface that cuts your code away from the Android framework so that you can mock just those two functions, it's letting you, in a way, have code that exercise the UI without the Android framework. So it sounds really good, right? And it has been around for a long time. So the second part of your question is whether I would recommend using it, and that answer has changed over time. So in the beginning, I would not recommend using it because first of all, it has the API is like different from how you would normally use an app, right? So it will ask you to now I don't remember precisely, but along the lines of, so when you use an app, the system calls your onCreate function, right? And you go through the cycle of onCreate, onStart, onResume. In Roboelectric, you have to manually say, all right, I have an activity like call onCreate and then see what happens. So like that's quite different from what you would normally think of as exercising running an Android app. And also, it has a lot of, the way it's done is called like shadow activities, which is not really doing what you would expect. Well, you don't know what the shadow activity is doing in terms of how much fidelity it has with the actual code that runs on your device. So there is a risk of your test running and passing on Roboelectric and failing on the actual framework. Now, I don't actually have statistics of how often that happens, but just the fact that they are two completely separate database, like, well, not database, like code base, like give me pause. So fast forward a few years and Google has acquired the Roboelectric team. So now RoboElectric is actually maintained by Google. So that gives me more confidence that it will be closer to the actual Android framework. And also, because it's now a part of Google, they actually unified the API for RoboElectric and Espresso. So you can use the exact same syntax to write a RoboElectric test versus an Espresso test. And most of the time, you can pretty much just put your RoboElectric test in a shared folder there's some setup you need to do, but you can essentially run the exact same test on both RoboElectric and Espresso. So that is a great way to verify that you are going to also pass your test on device, because you run Espresso on device, right? So then you could, if you set it up correctly, have a bunch of RoboElectric tests that run very quickly because it runs on the JVM. And then once maybe once a day or something, run it on Espresso to make sure that it still is passing on device. So one final thing for RoboElectric is the startup time is really slow. It takes like 5 seconds to spin up that whole fake environment, the fake Android environment. So it's not good for TDD. So if you're trying to write, if you're thinking, oh, JVM test is really fast, so I will use it to do that test-driven development where I change a little bit of thing and I run my test and verify it's passed and come back. RoboElectric is actually slower, surprisingly, than Espresso. Because Espresso, once the emulator is up and running, the deployment of it takes maybe half a second. And then you have to exercise the UI. So you're talking about 1 or 2 seconds, which is still faster than 5 seconds. However, that's the initial start time. So if you have, say, 100 tests to run, the first one is going to take 5 seconds. The second one is going to take 10 milliseconds or 15 milliseconds or 20. Like it's in the sub-second, the way sub-second range. So RoboElectric is very good if you want to iterate through a big set of tests. And then you can then, if you have this newest unified API, also run it on device with Espresso to make sure that the mock done by RoboElectric can be trusted. Long answer.
Great. No, I like it. That's really good information.
Yeah.
And then mentioning Espresso, do you have any tips, or can you describe Espresso a little bit, or any tips you might have with working with that?
Yeah, so Espresso is a way to write UI testing code. The way it's structured is that it's a little bit different from how you would normally think of an app, right? Because when you have an app and you have a button, then you do find view by ID, you find that button, and then you can click on it, you can change the text. In Espresso, there's kind of a formula where you call on view. So you call on view with ID, and then you give it the ID, say r.id.button. And then you can say .perform and then click. And then you can say .check matches with text OK. So the reason why it's structured like that is because when you have that first call for on view, it actually not just look for your view like on find view by ID, but it also triggers that the mechanism of testing that is so important, which is wait for your app to be idle before testing. So meaning I need to wait for this button to render so that I can click on it, right? So when you go through that, it's the Espresso system. It has a few notions of idle. It has that the UI thread is idling, meaning that it's not having events queued on that message queue for the UI thread. And it also checks that there's no async task running, which don't use async tasks, so it's not that important. But that notion of idle, you can also add new conditions. So that's the idling resources. For example, if you have network calls, let's say you use retrofit with OKHTTP, you can define a idling resource that make sure that we don't have anything that is going on with the network call through OKHTTP, and then register that idling resource with Espresso, so that when you say press that submit button and it goes to the network, which again you should use a mock one, but still it is still the network, and Espresso will not, like when it comes to it say like press the button and then later it says verify that like the smiley face is visible because you submitted a comment, right? It will not try to verify that the smiley face is visible until your network call finished, because when you do the on view with ID out.id.smiley, that call is going to say, hey, is there anything happening right now? Oh, the network call is happening, so I'll not do this line until it's idle. That means that the network call is done, the render is done, and it moves on. So I can talk for another hour on Espresso. At least, I mean, literally, I actually have 2 online courses teaching just Espresso, and each of them is more than an hour long. So
we'll make sure that we have the links to those courses.
Yeah, if you're interested
in the
in
show
learning
notes.
more, I think that will be a more structured way, and you can actually see the code and the diagrams instead of just me describing things with my voice.
It looks like magic watching the Espresso work. The first time I saw it, having never seen it before, I was just like, that is just amazing.
Yeah, because
so
someone
it's
is
very
the
cool.
button, but it's not me.
Yeah.
How? Yeah.
So that just blew me away, being a person who'd never had any experience with that before. It was very impressive.
So if you're migrating code, talk about the process of migrating the tests to match the migration of code.
Can you tell me a little bit more what you mean by migrating?
Well, if you're updating your code base that is affecting your tests, can you talk about updating your code and your tests and how you do that either in parallel, one then the other, or is it dependent on what the test is?
Okay, so let's use an example. I think that will make it a little bit clearer. So for example, I have that pin pad application, which has right now 2 lights, right? It's the green light and the red light. And I got a new model that has a multi-color LED. So now it's actually just one thing, right? So I need to swap in this component into my UI so that all my logic still works. Now, there are multiple ways you can do that, right? You can either have that both the new and the old at the same time and then get rid of the old. But that will probably be my preferred way of doing that. So for example, I will have, I put in that new multicolor LED, I will just call light. So instead of like change green light and then on and off, it will be change light, and then it will take a different parameter, which is the RGB code for the color you want it to be. And you can give it black to mean to turn it off, right? So then I will come in and run my test. This is just an additional light. It should not change anything because I didn't delete any light yet, right? And then I will come in and then I will, in each of my tests, I will also verify the state that I expect this light to change, right? So I come in, I do that, and it should fail at that point because I have not changed my app yet. So this is the classic TDD, you first write a failing test. So for example, your initial test says change, the green light should be on, the red light should be off, and then I add an extra line and say, and the light should be of color green. I run this test, it should fail because I have not added that logic into my app yet. Then I go to my app and in that if loop that says, oh, if the pin is correct, then I will turn on the green light and I'll turn off the red light. Then I'll add an extra line that says, then I will also change this light to green. And I'll repeat that process with all my tests. And each time I write, I say, okay, in the old well, because I can see, right? In the old well, it says that the red light should be on and the green light should be off. So then in my new test, I will say the light should be red. And then in the next test, I will see that the green light should be off, the red light should be off. And then in the new test, I will say the light should be black. And each time as I do that, it will fail the first time because the app hasn't been updated yet. Then update the app. And then once I have all my tests updated to involve the new light, then I can delete the old light. And again, the reason why I do it in this sequence instead of just putting the new light and rewriting everything is because my test is documenting what my code is supposed to be doing, right? So I don't have to think about, oh, right, okay, in this case, I press 1, 2, 3, 4, and the code should be 4, 5, 6, 7. It should be a red light on, right? Because the test literally says the green light should be off and the red light should be on. So that makes it much easier as I'm updating.
I found that if I actually take the idea of whenever I'm putting in a feature or if I'm making a modification, I think of it as tearing out a wall in my house to put on a new room. So instead of actually going right to work and taking a hammer to the wall, I try to make a little model of the house, or at least a model of the wall that I'm going to be working on. And that's that idea of making an external version of the application. So I sort of hack on it there, and that's where I make those changes. And then once that's done, and I've got sort of my little model off to the side of how did I make those changes, now I do it on the big scale and glue it back into the app.
Right. Yeah, it's like, well, nobody actually does that, but when you get a stain remover, they always say, test it on a small piece of your garment first before you ruin your actual code. This is exactly what developers do, right? Like, you just go right into your app and then no, test it on a small piece of garment first and make sure your stain remover just doesn't bleach everything to white. I know we all need more discipline in our life. But at least like in the world of testing, a lot of people don't even know that this is what you're supposed to do. So that's the first step.
Well, some of us have that discipline, but then we have PMs who don't know about that discipline and they say, I want it yesterday.
Yeah, and then you put that stain remover on your whole dress and then it becomes white. Oops.
I'm really looking forward to the conference coming up in July. Could you tell us any sneak previews about what to expect this year?
Yeah, so if people are not familiar with the 360 NDEV conference, I should be just explain a little bit. It's a Android conference that's happening in Denver in July. So this year is July 18th and 19th. And last year we tried something different, which is single track. Which was a great success. Initially, I was a bit worried because single track means that everybody is going to sit in the same talk, whether you are buying the ticket to go to this particular session or not, right? So when you have a 2-track, at least you can choose between 1 or 2. But the nice thing is that everybody has the same experience. So during lunch hour, you can talk about, say, oh, what do you think of that talk? And you know that the other person went to that talk. Well, unless, you know, he has an emergency call he needs to take. But this year, we have a lot of really interesting topics, and it's already on the website. So instead of me trying to come up with it from memory, I'm going to go to the website and take a look so that I don't promise things that we don't have. And that's 360ndef.com.
We'll have the link to the con in the show notes.
Yeah. So we have not just Android talks. We actually have, for example, a Flutter talk. So if you're curious about, oh yeah, all my users are like, I love your Android app, but then my girlfriend who uses iOS cannot use it. What do I do? And then you hear about Flutter, which is a cross-platform development tool. Maybe I should look into it, but you don't have time to necessarily devote a project to it. You can come to the conference and learn about it in 45 minutes. We also have machine learning on Android. Machine learning is super hot. Everybody thinks that everything should be machine learning. Is that true? Spoiler, not really. But I'm not the speaker, so I'll let the speaker give you her take. We also have a talk for you iOS developer out there that compares Swift and Kotlin.
Ooh.
Oh, nice.
Yeah, because it used to be that iOS people use square brackets and put function like parameters in odd places.
Oh,
because Objective-C have a very different syntax from a lot of other languages, unless you talk small talk, right? Like I'm not, you know, old enough to actually have the whole sequence of evolution of programming languages to find Objective-C intuitive. But now we have Swift. And Swift and Kotlin are surprisingly similar. So there's a talk that actually, I think in general, I like more crossovers. So which is why I'm highlighting things that are not like that. Machine learning, Flutter, Swift, things that, because day to day, we're so busy with our code. Like we need to ship those features, we need to fix those bugs, that you don't really have a chance to like look a little bit beyond your immediate and realize that, oh, there are other concepts that I may be able to use in my work. So those are just a few talks that I thought, okay, that I'm not expecting that to be in an Android conference, but actually will be useful. But we also have like more classic Android talks, like configuration changes, how do you deal with rotation, things like that. So I am very biased, but I think it will be a great conference.
And again, there is a 15% discount if you use the keyword Wenderlich.
Yes.
So that's
thanks
awesome.
for listening to this podcast, and I hope to see you at the conference, and you have a discount now.
Excellent.
Yes, I can't wait. It's one of my favorite events. I've gotten to go every year since it started.
Yay!
Tonight we've been talking with Chiu-Ki about Android testing, and I've certainly learned a lot about everything, and I'm really looking forward to her conference 360 AndDev coming up in July.
It's been a real pleasure having you on the show. Thank you for joining us.
Yes, thank you very much for joining us tonight.
Now we've got another show coming up in 2 weeks, and it looks like our guest for that one should be Romain Guy.
Yes,
exciting.
So that will be very exciting. I saw him on stage at Google I/O this year. Great, that wraps things up for this episode. We'd like to thank TripleByte, our sponsors tonight. That's TripleByte, BYTE. And back to you, Ray.
And that's a wrap. Thanks again, everybody, for listening to the RayWenderlich.com podcast. We hope you enjoyed it, and don't forget to leave a rating on iTunes. See you next time.